So hi, it's David Strom here in St. Louis. We're talking with the Blue Gear Ticks of Lincoln, Massachusetts. So tell me what you guys actually invented. I see you got some kind of model here. So obviously this is not life-size.
Yeah.
So what a stent is the thing you put in your artery to keep your artery open because you eat too much bad food. You guys don't have to worry about this at your age, but in mine you do.
Well, some kids have to get stents because they have a congenital heart defect and they need their arteries to be held open with a stent. And kids grow, so they have to get stents over and over to...
They got to replace them.
Yeah.
Right, and oftentimes the stent will actually stick to the artery, and when the rest of the artery grows,
it becomes another way to block it.
Yes, it becomes a blockage or an inhibition actually. So they may need to do invasive surgery to remove it, which is
so what is your
pleasant.
invention? How does it fix that? It expands as the artery expands.
Yeah.
So basically, we put this in the blood vessel, and when it's in the blood vessel, and as you know, children grow but stents don't. So we need to we figured out a way to make the stent grow, and so we would use an outside heating.
In this case, the blue right there is our wax, and you can hardly see them, but these wire cables right here are S-fold. They're kind of they're shortened right now,
and these will spring. So as soon as we release this is the only thing that is holding it smaller now. And so when these release, when the wax releases, these are no longer stuck to the to these crosses. And
so how do you control the heat so that it doesn't? Like, what if you're getting a tan or something? Won't that melt your wax?
You want what this will do is you have to have a heat at the stent of 110 degrees about. So.
How much money did you raise to do this?
Well,
and you have to raise the money yourselves, right?
Yeah.
The coaches and the parents, they can't.
They
I'm
can.
sure they help, but.
Yeah, they can help us, but we have to do it on our own by the end.
And how much time did you spend doing this whole project from start to
Well, we started like last year May actually to begin the research project, and then we just kept on doing it like every Friday, even exercises too.
Okay.
And now you were runner-up. Are you disappointed that you didn't win the 20 grand?
No, I'm still really happy.
No, I'm pretty happy because I think it's more of an honor to get chosen by the patent office to go to Washington D.C. than to get $20,000.
So have you actually been to? That's in June, right?
Yeah, that's in June.
Yeah, it's very cool where they have the patent office. Cool?
What?
Oh, yeah, you were a little older.
I'm only 10.
You're only 10?
Yeah, so we're 10 through 13. Yeah, I'm
You're 13? They're 13? Yeah.
She came up with the idea to have a gear tick instead of a deer tick, and so we added on to her idea over the years.
Cool.
Got some big robots.
Now you got some spare parts here too, I see.
These are our attachment to the liner. This is one of the aligners from Paddywhack. As you see, it goes like that.
we can start our robot actually by going like that.
Yeah, missions actually.
Hands up. Here we go. Starting matches in 3, 2, 1. Let's go. Blue Ticks working quickly. Grab the patent. They all ride solo today, so grab the patent is fairly easy. If you guys realize, on the patent on the table, that center obstacle is a race obstacle. The teams must compete to get to their first. The team that gets first to that patent actually then will grab the points. So you'll see a lot of teams today competing to get to that patent as quickly as possible. So let's see how we're doing over here. New York versus Brazil. The Brazilian team making some changes to some components. What these attachments do is these attachments allow them to better accomplish each individual obstacle. Some obstacles require you to grab an item, some require a push. You may have to lift or open. That's the greatest thing about this competition is these kids get to try several different methods to accomplish a similar task. So the Jaguars you see putting their attachment actually is a net on top. So kids are allowed to use pieces from the Lego collection. And evidently the net is a part of the Lego collection. So you'll also see this little white box in the corner. That white box is called our home base. That home base is an area that the kids are allowed to touch the robot without penalty. You'll see the robots from time, they'll start from that box, they'll go out to the obstacles, they'll come back to that box, and in that box is where you'll see the kids make their changes. It's just like a pit in NASCAR, but this is Lego Robotics style. Alright, we see the smart team. They're finishing up. Looks like our team from Spain is already finished.
So I'm here with Scott Evans. Now you designed the playing fields. Is that you do that every year for FIRST? Or is that
Since 1999.
and where do you get the ideas? I mean, these are pretty wild things that you have these bots doing.
A big group brainstorms on what the topic will be, and then we have a group of experts from that topic visit us and tell us about problems and wishes and hopes they have for that field of science. And then I close the door for about 8 weeks and decide what missions would make sense.
It takes you 8 weeks to do all this? Wow.
6 weeks, 12 weeks, you never know.
That's fine for you to see these kids.
Well, these particular kids, it's very unnerving because I'm looking at the best 1% in the world, and they make all the stuff that I thought should be reasonably hard, they make it look easy.
Right.